So, hello everybody, just wanted to do a quick update here and just show you that I found one of my backups, working backups, non-tomato, my revision 3. So I got 2 sticks. Well, I'm not sure yet. Let me just test it and see if we're breaking things. Yes, okay. So we are. Perfect. Okay, so my revision 3 was using my development with inverse kinematics. This is my jitter. Not my jitter, this is my Unity Physics Inverse Kinematics projects. That was my revision 3. And here, in order to lower the character, you have to. Oh, it's the block. Where's the block again? Let's remove this. Yeah. Okay. There we go. And we see the inverse kinematics. Now the legs. Everything is through the editor though. Okay, so that's a little bit annoying with my projects for the most part. All the time, it's always through the editor. You know, there are whips, drafts, and character controllers. It's not really my forte. I'm trying to work on one. So it works. You see the feet. If you watch the feet there and the legs, you know, inverse kinematics works for everything. It works also for the arms there. If I pick my controllers up, you know, in the Oculus Rift, and that I point the black stick towards the chunk, there's a projectile that it shoots, and it destroys the chunk that can be much bigger than this, and using my vertex triangle reducer. Okay, so if we look at the this here, you're gonna see now if I point it again. You think that it's not going through, it's not creating a hole everywhere, but it actually is. It's just that you can't see the faces from because they are. You can see because it's neighbor. It's my development on the neighboring chunks, you know, that I learned from Craig Perkles for first Minecraft tutorial to make sure to not build faces when there is a near chunk. If you know the bite is not transparent. Okay, so see here, you know, so it's pretty cool, and we could make the chunks bigger too. It's been a while that I opened this though, so let me just verify here. If I change the plane side, I would probably have to change it everywhere else. Oops. Yeah. So it was a little bit problematic, in fact. So I'm gonna close my my repository. Because I noticed, you know, like I wanted to put a license on my work, you know, my whole work of building this this whole thing up from scratch. But I just noticed after a long time already that I'm using assets that I purchased through the store. So the goal was not to put those assets for free. Hopefully there's a licensing thing inside of there that won't ever allow people, you know, from different license than me to use those assets without purchasing them. So I'm not sure though, you know, so I just want to make sure that so yeah. So you're gonna be able to maybe replay those later on when I remove all of the assets that I'm not even using. For instance, the IIS Central Dispatch, and I think I removed my other one there. Let me just see here if I could remove this. Before that, I'm just gonna take the project and actually move that to my folder there to make sure that we have a safeguard, safe backup of, oops, so you know, I'm getting better also for these kinds of things. It's just, you know, don't expect people to be perfect, especially when they're that far in a project and they want to make sure that the project, you know, stays alive, that they're not going to lose the backup and the black corners, the very dark corners of our hard drive where there's nothing else but programming projects everywhere, that it's impossible to find which one is actually the latest one, you know. So uploading those in a rush is always making us do those kinds of mistakes. So yeah. So we're gonna see if I can. Well, first I need to reload this, and I'm gonna clean those projects, those 3 projects of the jitter and the Unity physics and inverse kinematics, exactly for that reason before re-uploading everything. Or I'm gonna remake the projects from scratch. I'm not too sure yet, because when I'm trying to upload that to GitHub, it doesn't work for my latest revisions that I'm doing on my inverse kinematics there. So very frustrating for that, but you probably saw my post. So, compute voxels. This one here, we're going to remove the project so that we can reload it. So, and I'm not making prefabs, and I'm not creating the mesh from primitives and modifying it from there. You know, it gives a lot of problems. So at least I was able to build a couple of things in my portfolio there. Nothing is perfect. It's so far from being perfect. But at least if it can give a starting point, you know, a starting point for people to develop their own things. And, you know, that's a thank you to the tutorials that we're finding everywhere on YouTube or on GitHub that have MIT license or Creative Commons license or open source projects, and we're able to just learn from that and build our own things. So yeah. So here it's an old revision still. I was further ahead than this because I was able to assign the objects, the game objects, to the proper 1/8 divisions of the planet inside of a parent object. So unfortunately, so I called it still Rev 3 because I tried to bring 2 other ones, but you know they all suck really. Okay. So there, except that one. Rev 3 is where I started building things in a coroutine or something. So it's a little bit faster. Works. Faster rev per frame. Yeah, per frame work. Per frame mesh. Per frame create mesh. Yeah. Okay. So that's going to be another project here. So as I was saying, as I was displaying, well, if I do them in order, actually from my post here, because I just posted on. Just a moment. Here, there you go. So I showed you the planet. So the 3 revisions are pretty much the same there. Oops. And now I've just loaded the essay terrain, which is the second example here. Unfortunately, it's using my vertex triangle reducer work that I did, and I don't have any shader prepared for that. So I'm using the shaded wireframe from Unity's tool, so that you can see that the vertex are really, the triangle faces are really reduced there. Okay. So, oh, and for that example, you can move, but you've got the limit. Okay, the area chunk is the limit. It's very small, but you're able to move and have the terrain generated within that that distance, the distance that the chunk covers, the array chunk covers. Okay. So unfortunately, the other meshes are not getting out of render when you're moving the player, so that's something left to be fixed. Okay. So there you go. We're at the limit of that on that side. We can go on that side. And we're gonna be at the limit. you know, and I'm not lerping the positions also. So if you move too fast, we're gonna have gaps. Okay, so it's a simple basic thing right now. Okay, so if you move too fast a player or something, it's not gonna build what's with the location from where you were to that new location, because I'm not lerping and I'm not storing the positions of movement inside of an array that could say, oh, is there a new chunk there? Yes or no, and build the chunk. I'm not using that. So if you're not using it yet, I want to develop that at some point. Okay. So this is this example here. Okay, vertex triangle reduced. Okay, we have no faces for the bottom on that example though, as that's where I was at when I had made the backup of this. Okay, I wasn't working on a bottom face, didn't need it at the beginning, you know, to see at least if it was working what I was doing. Okay, but that's something I can fix in the future. Okay. So we have a lot of vertices, but we have much less vertices than if I was using my non-reduced version of the same thing. That's something that I can do also later to include a version for this. So, you know, that's about how big this chunk is, and unfortunately I didn't put the objects, game objects, inside of this main object there yet. That's something that I'm also going to do. Okay, next, this one here, vertex triangle reduced, and the map is being constructed also in the shader. Okay. So using my triangle reducer script in development, and the map is being built through the shader and outputted to the CPU, which takes the map and starts working on creating and finding the vertices and creating the vertices. Okay, so I wanted to improve on this because I wanted to have at least also the vertices being worked on from the shader. So I didn't entirely succeed where I want to go with that. I still had things to develop. I did try and to bring my vertex triangle reducer inside of shaders, but it doesn't work yet. Okay. Oh, and each one of those chunks is oops. Each one of those chunks is a mesh, okay, with all faces already combined from scratch, as shown in the tutorial of Craig Perko, the first Minecraft tutorial of Craig Perko. Okay, got issues with the faces though here. You see, there's a problem, so that I need to fix, you know, inside of my vertex triangle reducer. So it's not perfect yet. Okay. Just one chunk combined, and the chunk within are not drawn. Okay, and there's nothing drawn within. The neighbor check is not done here. The neighbor check, in order to not draw faces that are not transparent, just like you can see there, we don't have that there. But if we return to the planet for 2 seconds, the faster version of the planet, okay, you're gonna see that in here I'm calculating also the calculating also the neighbors for every chunks in order to not have any extra faces. Okay, that's why you can see that everything within it is transparent. Bring this chunk out. Okay, transparent. Okay, and you can see within also, within the planet, if you see the meshes here, I built also certain layers. So you have the top layer, which is like the crust of the planet, and underneath of that you have, you would say, the dungeon area, you know, so that if I take a big division here, yeah, you're gonna see that within the chunk is a different kind of purlin, different values for the purlin. So you have more of a like cavernous area there, where there's There's a possibility for digging and finding caves and stuff, you know. Okay, so if we bring that there also. Oops. Okay, you see there's holes everywhere. You know, in that purlin from inside. You know, like different purlin. Okay, so then we have a mountainous area, kind of outside-ish. In some places, the rest is flat. So it was my starter work, basically, almost. Okay. A little bit faster than my revision 2 and 1, which are quite the same there. So I might even, you know, remove the revision 2, so I'm not even started. And I didn't check the scripts, and it seems identical backup to Rev 1. Okay, so we didn't try, so I need to make a prefab of this one too. Okay. And now, in here, I'm able to compute the map and compute the vertices locations, and the vertices locations are then outputted to the CPU. They're given back to the CPU for the CPU to create the vertices everywhere that it finds a location. Okay. And uses that location to create the vertices. So it's not that bad, but here I was using, I was not putting the, what was it not doing? There was something, yeah, I was using many scripts to achieve this, and all naming the scripts one by their type of faces. So my next revision was to combine everything inside of one script. Okay. So one script, but we have also the same thing, same chunk, and the faces also, they're separate. You can select which type of face that you've built. In voxel, you know, the top face. Is that the top face? There's more than one top face. Oh, okay. What the hell? Top face is here. Oh, I need. Yeah, there seems to be like more than one top face or something. No. What's going on here? Oh, I'm using two projects at the same time. Yay. Okay, so sorry about that. Okay, so it's pretty much the same thing as the other project right before, but everything is combined. The scripts, I mean, just one script to generate all the faces, and then each time there's a different face to load a different shader for it from script. Okay. to stop that stream. So I'm gonna try to re-update, do a re-update soon, but I'm gonna work a little bit more on things prior to that. Okay, do some more corrections and some more add-ons and stuff. Okay, so thanks for watching.